Thank you, everyone, for joining us today. My name is Erin Daly. On behalf of Everbridge, I'm excited to present this Expert Insights webinar, Winter Weather Forecast for 2013-2014, Predictions and Best Practices with WDT. In this webinar, our presenters will examine what's in store for the upcoming winter season, best practices for leveraging forecast data, and solving winter weather communication challenges. After the session, we'll have a 15-minute Q&A session with our speakers. So now I'd like to introduce you to our speakers. From WDT, we have Jason Lin, Senior Vice President of Forecast Services. Jason has extensive knowledge of forecasting tropical storms and short-term hazardous events. Many very large trading floors have utilized Jason's forecasting skills during tropical events, severe weather events, and cold outbreaks. He is one of the few accomplished operational global synoptic dynamic model practitioners in the meteorological community. Jason has an MS in meteorology and more than 8 years of combined experience at the National Severe Storms Laboratory and the Storm Prediction Center. He has also handled extensive asset protection responsibilities for 2 significant energy companies in 5 of his 11 years in energy space. Mike Gauthier is Senior Vice President of Business Development and has led the WDT North American sales operations since 2005. Prior to joining WDT, Mike served as Vice President for Impact Weather. He also previously served as the Chief Operating Officer of a medical supply company. Mike has extensive experience with business continuity and emergency management and over 25 years of sales experience in the weather and outdoor recreation industry. And Dr. David Gold is our Senior Scientist and Forecaster at WDT. David has a PhD in Atmospheric Science and an MS in Meteorology from Texas A&M University, along with over 6 years of meteorological support experience in the energy space. He has independently developed several proprietary analog and pattern matching tools, as well as a sophisticated framework for performing regression-based and canonical correlation analysis based weekly, monthly, and seasonal forecasts. David is an extremely involved and respected member of the private sector meteorological forecast community and has a special interest and expertise in identifying type of pattern transitions that lead to severe weather outbreaks and the large-scale patterns that tend to support their occurrence. So after WDT's presentation, we'll be hearing from Claudia Dent, Vice President of Product Management at Everbridge. Claudia has many years of experience in the technology industry and has held executive positions in product management, marketing, business development, and general management at companies ranging from startups to large global enterprises. We're excited and honored to have all of our speakers here with us today.
Good afternoon, everyone. This is Mike Gott here with Weather Decision Technology, Senior VP of Business Development. I'm just going to kind of set the stage here for what we're going to discuss today. Just take about 2 minutes of your time. Really excited to have this opportunity to do these webinars with Everbridge, as I feel the combination of what we both do very well is the complete answer. We basically talk about what falls sky and affects the ground, and then they help you communicate that throughout your organization. Jason, if you want to hit the next slide, please. Just a quick overview, a 30,000-foot overview of Weather Decision Technologies. We're an industry leader in decision analytics and information services in the weather space. We deliver a big data solution globally on a software as a service-based solutions via web and mobile applications, helping organizations and individuals make mission-critical decisions that are impacted by the weather. And we'll have a little case study at the end of our forecast section here. Go ahead, Jason. Hit the next slide real quick. WDT is located at the southern end of the University of Oklahoma's National Weather Center complex. We're actually on campus down here. This slide, we actually have 85 employees now, 40 plus with either PhDs or masters in meteorology. We are the absolute leader in global meteorological content, providing solutions both internationally and domestic from everything from the media that you might see on television and television websites, mobile applications, to working with very large Fortune class companies doing site-specific hyper-local alerting and asset management, long-range forecasting, and data composition for common operating pictures around the globe as they expand their operations. And we do quite a bit of customized research, as we'll show you on an example at the end of this. Want to set this up and just tell you that the next few minutes we're going to discuss how we worked in a previous seminar. Jason Lynn's going to discuss how we pretty much nailed the forecast with all the fun winter weather that hit this country the first part of December. And in fact, locally here, we worked with OG&E, the local electric utility, to actually help them pre-position assets and make sure the power stayed on. It was very successful. So with that, I'm going to turn the ball over to Jason and let him kind of take you guys through better guidance through better science. Go ahead, Jason.
Thanks, Mike. Here at the WDT Weather Ops Forecast Services Group, we basically start with great science, apply advanced forecasting methods, and leverage advanced observational and forecasting tools to tell people when bad things are going to happen. We can start out all the way at the next 30 days. And let's see here, hold on. Aaron, I need to stay presenter.
My apologies. Let me bring you right. Are you all set, or do you need me to?
I think it was passed to Dave. I need to stay presenter.
My apologies.
There we go. No problem. Getting back to the generalized statement, we can start the setting the stage for increasing situational awareness for hazardous events all the way out into the subseasonal space, which is about a 30 to 40-day lead time, and maintain that situational awareness with our product suite all the way into the tactical view, say like in the next 5 minutes with a severe weather warning. We believe better guidance can indeed be achieved through better science. So for the next several minutes in this portion of the presentation, I'd like to highlight some quote-unquote best practices employed by WDT, but from a forecast generation perspective. And I'll do that by showing some verification of some of our forecast products this winter within what we call a forecast funnel paradigm, which starts with a very broad, strategic, generalized winter pattern forecast set of statements made during our last webinar for Bridge back in late September. And I want to narrow that down to tactical forecast products made for a high-impact winter storm event that occurred here in the Southern Plains and in the Midwest earlier this month. I first want to very briefly describe some of the meteorological philosophy we believe represents a best practices approach, especially for the medium range and subseasonal forecasting time frame, which covers roughly day 5 through about day 40. A very wise and experienced meteorologist within the University of Oklahoma system once told me, you need to understand now in order to make a forecast for later. We employ that kind of process here at WDT, illustrated in very complex fashion on this workflow diagram slide. First, involving observation and diagnosis of why the current weather pattern exists, what features, what physical processes got us here before we look at numerical weather prediction computer models at the bottom of the flow diagram, flow from top to bottom in this case. Most forecasters that we've run across in my 11 plus years of operational forecasting, both in the private sector and in the public sector, actually start with computer models at the bottom of the flow chart. And that skips many valuable steps in recognizing the features at different time and space scales at work that actually produce our weather. These features include slow-evolving processes like El Niños and La Niñas that you're probably somewhat familiar with, to medium-paced processes like tracking focus regions of thunderstorms moving through the tropics that can affect the wiggles in the jet stream, called MJOs, to very fast-paced processes like individual storm systems moving along in the mid-latitude jet stream. If one skips right to the model step, we reduce the meteorologist to simply a model interpreter, which can lead to a rather incomplete picture and understanding of what the atmosphere can actually do. This winter to date provides us with a pretty good example about how incorporating diagnostic information at multiple time and space scales with numerical computer model data can actually improve the quality of the forecast guidance. WDT's senior weather climate research scientist Ed Berry and myself led a webinar back in late September in which we presented some explanations behind some of the classic winter hazards with various precip types and extremely severe cold air, along with some generalized predictive statements about how the upcoming winter would unfold. Given the current state of the science of meteorology, without really large trends in an El Nino or a La Nina condition out in the Pacific, forecast skill on a monthly time scale can be very low. We essentially had a neutral situation heading into this winter, with maybe a little bit of a trend towards a weak El Nino onset, but there were no clear-cut set of processes that we could identify to keep that trend going. And so confidence in a multi-month winter forecast, like for November all the way through February as a composite, was actually very low in late September and early October. The graphics on the left portion of this slide show the primary favored computer model forecast information available to us at that time in late September going into early October for the November, December, January 3-month composite. And these models resonated some with us since they suggested normal to below normal temperatures in the northwestern and north central part of the U.S. and above normal temperature risk across the south. And there's a common theme in those two models on the left side of the slide here for ridging, warm air ridging up through Alaska and cold air moving south through either western or central Canada. The lower left graphic is the National Weather Service Climate Prediction Center forecast for the same time, November through January, which is quite warm over pretty much most of the southeastern half of the nation, and their forecast showed no major cold risk anywhere at all in the lower 48. When we applied our forecast process at that time, including input from some of our advanced internal forecast techniques like the GWO phase space anomaly plots shown here in the middle part of the slide, those techniques helped us identify some physical processes at work that supported a few general predictive statements. First, we called for the first half of winter to feature pronounced cold risk over the northwestern half or a little bit more than half of the U.S. and warm risk over the southeastern third of the nation. We also expected elevated risk of high-impact winter storms through the central third of the nation, especially for the plains down reaching into Texas, and then ejecting east-northeast from there through the Midwest and interior Northeast. And finally, we speculated that the overall cold risk in the first half of winter in the Northwest could eventually evolve more severely eastward by midwinter into late winter. And on this graphic, on this slide, the far right graphic shows the verification to date, the Northern Hemisphere temperature anomalies so far this winter from November 1st through mid-December. And from that graphic, we can derive some pretty clear results and judgments. First of all, cold air has indeed been a rather prevalent piece of the weather picture over the northwestern half of the U.S. so far this winter. However, delivery of that cold air and southeastward expansion of that cold air has occurred much stronger and faster than pretty much any forecast expected that we were able to find from either a vendor or a computer model. And we offer up the idea that this farther east and more aggressive cold air expansion has been driven in non-standard ways, which our forecast process partially identified, but the signals in late September weren't strong enough for us to get this aggressive. And the final point I want to make is clearly there have already been multiple high-impact winter weather events in the plains, the Midwest, and Northeast. and we're on the cusp of another one occurring over this weekend, leading right up into travel for a lot of folks before the Christmas holiday period. So overall, our generalized predictive comments were pretty solid at a long-term strategic level on multiple fronts, but they weren't aggressive enough with the cold, nor aggressive enough to spread the cold far enough southeast. However, as the forecast time horizon shifts to a more mixed strategic tactical time horizon, getting closer in rather than a 3-month composite, but now getting inside a month, WDT forecast products zoned in on the pattern evolution and hazard threats with better accuracy and detail. This next slide group shows a transition of WDT forecast products from a week 3-4 lead time in that subseasonal space to a week 1 lead time for a major cold outbreak and winter storm event that occurred December 5th through the 9th. We start here on this slide with a subseasonal 16 to 30-day outlook made on November 18th, covering pretty much the first half of December, showing cold air available from western Canada and down into the plains and Midwest at times during that 2-week period, with elevated storm risk in the dotted green area from the Arklatex into the Midwest. And in the upper right, a rather conservative National Weather Service Climate Prediction Center full December composite forecast is shown. And in these next few slides, I'll also show CPC forecasts for roughly the same periods in the upper right. In this case, the Weather Service forecast was very conservative. No below normal anomaly risk southeast of the Dakotas. Rolling forward, we're now at an 11 to 15-day forecast, which we issued on November 25th, valid for the key period we're looking at, December 5th through the 9th. And this forecast showed a more aggressive cold event through the plains, Midwest, and then smearing across the northern tier to the Great Lakes and Northeast. The forecast also included elevated storm risk from the southern plains to the Midwest and Northeast, now that we're out only at week 2. The overall outlook is refined further into this 6 to 10-day forecast, still valid for that early period in December, covering the near the 5th leading up to the 9th. This particular 6 to 10-day forecast was made before the Thanksgiving Day holiday commenced on November 27th. We now have a warmer look for the southeast ahead of the large-scale cold outbreak forecasted that has gotten colder with this forecast trend into the Rockies, surging into the plains, with storm risk over a large portion of the nation focused on the plains. Now looking at the verification, the actual temperature anomalies which occurred for the December 5th to December 9th period, it kind of drives home the ability of these forecast products to increase situational awareness of an elevated risk for a major cold air outbreak over the western 2/3 of the U.S. as we move forward from strategic timescales into tactical timescales. And the forecast includes addressing the major storm event summarized by the overall 5-day precipitation accumulation map in the upper right. That's a composite for the 5th through the 9th, which shows a significant precipitation event occurring first over the southern plains, going through the Tennessee Valley into the eastern U.S., and then another shot of snow farther north from there from the central Rockies through the northwestern Great Lakes. Moving completely into the tactical realm, so this shorter-term forecast, WDT operations and products can represent examples of best practices in forecasting tools and communication methods for short fuse warning and short fuse forecasting needs for your average consumers, for businesses, for asset optimizers. These products continue to maintain the situational awareness during a hazardous event, reporting action from the decision makers while we as meteorologists fine-tune the forecast details in real time. Temperature anomalies going into December 5th and 6th, shown on this particular slide, at the start of the cold air outbreak and start of the major winter storm that developed over the southern plains, exceeded 20 to 30 degrees Fahrenheit below normal over a rather large portion of the interior west, Rockies, and spilling down into the plains. The storm structure that was set up for Thursday, December 5th, shows rather obvious similarities to what we call a prototypical Southern Plains and Midwest major winter storm. Low-level cold air is already in place, extending down through Oklahoma into North Texas on Thursday the 5th. And low-level cold air continues to press southeast into a lower Mississippi Valley that next Friday and Saturday. This is all well ahead of the main mid-level disturbance and the primary surface low pressure center back there over the southwestern U.S. and the southern Rockies. And this setup allows us as forecasters to engage the proper conceptual model of a storm system that actually carries enhanced ice accumulation risk, more so than snow, down to the Red River or into the western Tennessee Valley. The ice accumulation risk can be followed by moderate snow, especially on the northwestern flank of the precip shield. The top middle graphic of this next slide refers back to a prototypical schematic I showed in the late September webinar of a cross-section through the east side of a major winter storm system from south on the left to north on the right, where the battle rages between the depth of the low-level freezing layer and the thickness of that elevated warm nose to decide precipitation type. And precipitation type is an extremely important detail for managing preparation and the response for these events, especially in the southern U.S. Ice versus snow is a very big deal. The upper left graphic shows the actual vertical temperature profile during the evening of Thursday, December 5th in Dallas-Fort Worth, Texas. And this actual observation clearly illustrates the classic hallmarks of a freezing rain setup with a thick warm nose in that red outlined area overlying a shallow sub-freezing surface layer. Our forecast from Wednesday evening, December 4th, covering Thursday the 5th and Friday the 6th, is shown a snapshot of our IMAP Pro interactive system here in the upper right. This forecast features a large region, moderate to heavy freezing rain and sleet risk over North Texas, far southeast Oklahoma into Arkansas, that whole magenta area, which transitions to a wintry mix, then over to moderate snow farther northwest through Oklahoma and western Arkansas, but after starting as sleet. And that's an especially nasty setup to where you have ice at first and then covered snow in places that aren't equipped to handle that kind of setup. Across the bottom here, we have advanced WDT high-resolution model data, which very much aided our forecast process. This short middle, along with the forecast for the evolution of precipitation type there in the lower right, helped us fine-tune the forecast details so we could hone in on the right hazards, help promote the right responses from decision makers. The lower right precip type forecast graphic further increased our overall confidence to go ahead and stay with the significant ice storm type of conceptual model for this event. I'm going to close the tactical verification discussion. A few more pretty pictures. The first is from Thursday morning, December 5th, the forecast we made through Friday, December 6th, in which we tuned the forecast accumulation details to include up to an inch of related ice glazing, highly populated section of North Texas, through far southeastern Oklahoma into Arkansas. I was driving through this mess at the time, coming back from a business trip to Houston, and it was not a wise decision. Hundreds of accidents were reported in the DFW Metroplex Thursday afternoon, Thursday night alone, and 200,000 plus locations in the Dallas-Fort Worth area, just in the immediate metro, without power more than 2 days after the storm. The white star shows the location on the IMAP Pro image in the upper left of the two pictures here, where ice glazing was particularly destructive. Trees down on the power lines and trees down onto roads, and travel conditions were extremely treacherous. The Thursday morning forecast for Friday, December 6th into Saturday, December 7th, extended the ice and snow threat further east-northeast into the heartland. And again, I used the white star to denote the location of the attached pictures for extremely heavy icing followed by moderate snow, providing more stress, and power lines, and even more treacherous travel conditions. The graphic in the lower right shows the observed ice and snow accumulation totals. The example star location I picked received first 3/4 of an inch of ice and then 4+ inches of snow on top of the ice. These combinations in the south central portion of the U.S. are absolutely debilitating. Our lack of infrastructure present, which makes specific content of the forecast messages more important to decision makers so that they can set up for the right hazards. I'd now like to shift the focus from verification and turn it more towards predictive statement by passing the presentation over to Dr. David Gold, one of our senior scientists and forecasters here at our Weather Ops Forecast Services team. Dr. Gold specializes in medium-range and subseasonal forecast techniques, both generating the forecast products and researching ways to improve the forecast accuracy out there. So Dave, take it away, please, sir. And Aaron, if you could pass over to Dave.
All right. Thank you, Jason. Well, I will share a platitude from another Jedi master meteorologist who once said, just focus on the jet stream. And so I will start my presentation by doing just that. So what has gotten us to this situation? Why the high-impact, severe winter weather that has gripped most of the nation? Jason showed a couple of sample forecasts going into the winter season, which basically revealed that most of the pundits missed the this type of outcome. And one of the reasons why, also mentioned by Jason, is the fact that going into the season there were no obvious slowly evolving signals to hang our hat on. The main sources of skill for a seasonal outlook come from ENSO, the El Nino Southern Oscillation phenomenon, and the other is trend, climate trend. We've had a general warm trend, and the first was absent. The second factor was really of no use, obviously, going into the winter. And so what that means is it puts the onus on subseasonal forecasting to catch these types of events. And that's where the value of having a meteorology team with that kind of experience really comes into play. On this first graphic, this is actually a recent snapshot of the jet stream. And I've marked the location of some of the geographic land masses for reference. And this is a pretty good representation of what's been happening. In a nutshell, we've had jet streams extending east of Japan. Nothing terribly unusual about that for the winter time, except for these have been stronger and farther south than normal. And it turns out that as these jets come out, unless you're talking about a really strong El Nino event, what often happens is that their leading edge, the jet stream actually breaks down into these large high-amplitude wave packets. And you can see a good example of one. This is from last night, with a high-amplitude ridge sort of getting pushed along ahead of the jet stream, which I've marked as black arrow there. And downstream of that, over the USA, you can see what I've marked the center of that trough with a blue L. And this is actually an unfolding event right now. This is basically a packet of energy that's moving through the westerlies and successively amplifying high and low pressure systems eastward as this energy packet moves along. And right now, the peak of this packet is actually within that red high pressure system in the East Pacific. That's actually one of the reasons why the West Coast has been so dry. Downstream of that, we're going to see another large polar trough amplify and bring another round of high-impact weather, including some severe weather to the southern tier this weekend. That trough is going to deepen, and that energy will move all the way to Europe and create severe windstorm conditions and more severe weather down there. And this is the kind of event that just keeps happening over and over and over again and circulating around the globe. One of the interesting things about this, which I'll remark on in a moment, is the fact that there, aside from occasional kicks, if you will, from the West Pacific, and that's important, there really hasn't been much contribution from tropical rainfall patterns. It turns out that tropical rainfall patterns drive a lot of the variability that can lead to severe winter weather. And this year, that's actually been more or less absent, especially the last couple of weeks. Tropical rainfall patterns have been anomalous, but back to the Indian Ocean. And the Asian jet stream has actually outrun that rainfall pattern, and that's fairly unusual, and I think it's some evidence that suggests that we just have a very noisy pattern that consists of a lot of dynamics mainly internal to the jet stream, and that's driving everything. And so you, as a forecaster, you're having to keep track of these really fast, noisy processes to stay ahead of the weather forecast. So with that in mind, I just showed an unfolding wave packet event moving through the Pacific into the U.S., and that's the kind of event that has driven so much cold air into the U.S. In fact, one of the things I might do is divert here to show you a satellite image. And you can see here, you can actually see in the satellite imagery this jet stream extending out away from the east coast of Asia and then collapsing up into this giant high-pressure ridge, which is right now building into the Gulf of Alaska. And here's the downstream low-pressure system, once again digging along the west coast and about to eject inland into the central U.S., and more cold air will come in behind it, and high-impact severe weather, including some winter weather along with it. And so that's the kind of event that's been occurring repeatedly so far early this winter. And we expect another episode of cold air to come into the U.S. in the 6 to 10. This is the latter part of December, and then into the following 5-day period, heading through the start of the new year. You can see the expectation is for more high-impact winter weather and more cold, some Arctic air involved in this, and basically marks a kind of a repetition of the type of weather we've just seen, although probably not to the same extreme as we've just seen. So going forward, I think a key forecast issue is we have this big warm pool sitting out here in the West Pacific. And these are actually weekly average sea surface temperatures. And again, as I've stated, the reason that that's important is because enhanced regions of tropical rainfall like to set up over regions of the tropical oceans that are warmest. And the warmest conditions right now happen to be right here over the West Pacific, west of the date line, but east of New Guinea. And we think that chances are pretty good that tropical rainfall patterns will once again, will finally anchor to this region and come out east, much the way they did a few weeks ago when we had violent Typhoon Haiyan. We think that, fairly soon we'll start to see more and more episodes of enhanced rainfall here, and that could constructively interact with the existing pattern that we already have. And I've sort of schematically traced that out here with this black arrow, whereby you have this chain of high and low pressure systems culminating in deep Arctic troughs over the U.S. And with that in mind, this is a forecast that we've made. In fact, this was just updated by us this morning for the weeks 3 through 5 time frame, which basically is the first half of January. And if our ideas are correct, we could see yet more risk of widespread Arctic air overspreading most of the central U.S. I would note that one of the tools that we use in support of this kind of forecast is shown just above that. And this is a composite that we've generated in-house using our own composite engine. And what we basically do is we feed into it, we filter historical temperature data using the state of various climate indices that we think will be relevant for an upcoming period, and we look to see what kind of temperature risks come out of that. And this is an example of one of those products that we consulted when we generated this map right here, and this shows that with the kind of pattern we have now, and under the assumption that this warm pool lights up eventually, this is a reasonable representation of the temperature risks. And you'll notice modest cold skews here. But we're adjusting that colder given the recent observation of how amplified these high-pressure systems have become up into the area around Alaska, and how much Arctic air has therefore been available to be driven down into the continental United States with that. And finally, one of the other pieces of information that we consult when we craft a seasonal forecast are the climate models. They have gotten more skillful over time. And what's interesting is that the climate model down here on the left, this is actually a number of different climate models that have been blended together into sort of a consensus. And it's called the multi-model ensemble. And they're very warm for January. But notice they were also quite warm. In fact, I think this was one of the factors that the National Center consulted when they made their early forecast call for winter. And I think you'll recognize that from Jason's screen, this warm look from the desert southwest up to the Great Lakes. Well, what's happened month to date so far is obviously quite a bit different than that. In fact, it's almost exactly the opposite outcome, with one of the coldest Decembers on record unfolding right before our eyes. And so that shows you that even though they've become more skillful, they can't be consulted in a vacuum. You have to consider other things, and you know, I have to view this January forecast with grave skepticism. And the diagnostic information in front of us suggests that what may be happening is these climate models may be too insistent that the Indian Ocean will actually be the dominant hotspot going forward and will drive the pattern, and that typically correlates to a much warmer outcome, when in fact what's really been driving the pattern are processes internal to the jet stream, and that if anything, with the warm pool being displaced back to the west, as I showed earlier, or back to the east rather, as I showed earlier, it's much more likely that if we see any contribution from the tropics in driving the mid-latitude pattern going into January, it will likely be one that would constructively interfere with the pattern that we have in place now, rather than one that the models are suggesting, which could cause the jet stream to basically retract and everybody in mid-latitudes to warm up. So that's basically all I have for you today on the long-range outlook.
Okay, Aaron, back to me.
Everybody, this is Mike Gott here again. I'm just going to talk real quick about a case study using the intelligence of the smart guys I have around me. And this is a pretty interesting little case here. This was a large retail chain, you probably know them as Walmart, who back in several years ago in South Dakota had a significant amount of snow collapse the roof on a Walmart store, causing not only obviously shut down of the store, lost revenues, damage to their facility. Luckily no one was injured in this. Go ahead, Jason, just keep advancing it. That WDT then was hired to take our science and our best practice capabilities, and we actually monitor the snow amounts for all the Walmart stores around the country. We monitor then the snowfall falling on them and the liquid equivalent moisture that's in that snowfall, and provide the Walmart these totals in a format that their engineers can use to determine whether they actually hire somebody to go shovel roofs. And this is their third season using this. They love it. Haven't had a collapse since then. Walmart uses our skill sets to monitor their facilities, and we monitor their locations, and there's several thousand of these we monitor for snowfall amount using some of the techniques derived here at the WDT. So with that being said, Jason, I think we're going to turn it back over to Everbridge and go from there.
All right. Well, I just want to thank WDT for sharing those winter weather patterns, et cetera, with us. It's really interesting and helpful, particularly because I live in the Northeast, so I was definitely watching very carefully some of those patterns, etc. What I want to do today is just spend a little bit of time talking about preparing for winter weather and some of the communication challenges that you might want to consider as you move forward in any of your planning processes. So from an Everbridge perspective, when we think about preparing for winter weather, there's a certain checklist that we think about that we would recommend you consider. The main thing is managing the entire life cycle of any critical winter event or any event in that, of critical nature in general. But one of the things to consider is making sure that you communicate before the event happens, as the forecast is, formulating, making sure that you're prepared for what's going to happen, communication during the event, and then communication after the event. All those are equally as important. Because winter events can damage, power lines or compromise certain contact paths, you want to ensure that you have multiple ways to reach the people that are most important to you. We'll talk a little bit about message construction, how that's important, etc. And we'll also talk about how social media can help you understand what's happening from a winter event or a weather event perspective. And then, of course, it's always important that you always test your systems and procedures well in advance so that you're prepared and very fluid in your response to critical events. I would like to take a little bit of time to talk about how WDT really enables Everbridge to deliver weather alerts in a way that we call smart weather. So WDT is incredibly important to us and enables us to leverage their meteorological resources to enhance and prioritize and optimize over 150 different severe weather alerts that we offer and help you automate through our Everbridge platform. So WDT is a strategic partner for us and really is the underpinning of how we deliver weather information. So just, and this is just a screenshot of how that works. You'll notice in the Everbridge universe, you'll see on the left-hand side a blizzard warning. And on the right-hand side, you'll notice that that blizzard warning appears as a polygon in a map-based interface, so you understand very visually where that blizzard is going to impact. You can also notify contacts automatically, or you can select contacts from the map in an interactive fashion to update messages, etc. So that's how a little bit about how the weather alerting works within the Everbridge platform. It's important as you prepare for weather events that you think about the messaging that you're going to need to deliver to ensure that everyone is taking the actions they need to take, remaining safe, etc. And you always want to consider the fact that there are different messages for different audiences, based on the kind of weather event that you're considering. For example, if it's a winter storm event, you want to make sure that operations are ready, so there's messages that you'll send to your operations team to ensure that they're taking all the necessary actions. There's messages that would be more appropriate for community or employees, and these include things like parking bans, for snow removal, anything of that nature. And then, of course, facilities management also, needs to be kept up to date, etc. So if you think about these messages and you think about your audience ahead of time, you'll be much more prepared to communicate very specifically with each of these audiences, again, before, during, and after the winter storm event. We talk about multiple contact paths, and this is incredibly important. When you think about communicating with people, you want to target the individual and not just the device. During events, oftentimes modes may be compromised. Great examples during, Hurricane Sandy, during Nemo, where, landlines were down because of the impact of the storm. During the Boston Marathon crisis, communication was not available. So always, always have as many contact paths as possible for those that you need to communicate with. Message construction itself is also critically important. And there's an easy rule to think about. During the course of an emergency or a critical event, you want to make sure that all your messages are very clear and concise. So the 3-3-30 rule really means 3 short sentences, 3 key messages, and 30 words. And this rule is meant so that you can be assured that during a crisis, people will, understand exactly what you're trying to communicate, and it's within the capacity that people have during an emergency situation. SMS, obviously should be no longer than 120 characters in order to get important messages across. If possible, it's always best to have two-way mobile communications. This way with your constituents, whether they're employees or members or citizens of the community, you can get frontline information from reliable resources, even when there are adverse network conditions or connectivity. So this enables you to get pictures, what's happening on the ground from trusted sources, as well as have a two-way conversation with your constituents. And then finally, one other key element of being prepared for a storm and being able to respond appropriately is leveraging social intelligence. There's a lot of information out there with social media, and you can use and leverage social media to improve your situational awareness. And again, this goes for before the storm, during the storm, and after the storm. And some examples here include during Hurricane Sandy, after the storm, hospitals were desperate to try and staff their facilities, but were having trouble because many people could not find gas. So they were able to use social media to understand, what gas stations were open, where, how long the lines were to wait to even get gas. If people were waiting in line, when that gas station might have shut down because they were, out of fuel, etc. All of this was available via special filters that you can set up in Everbridge, leveraging our social media situational awareness capability. Another great example is, again, during Hurricane Sandy, being able to understand what the aftermath was, what was the damage that was done. And a lot of roads were really compromised, so getting a picture of what was happening, from social media was very helpful. Obviously that's quite a scary scene there with the telephone wires down and the tree down on top of them, which was, really dangerous. And finally, because we were talked so much about winter events, you could, from social media, understand, exactly what was happening in different communities around, how high the snow drifts were occurring, where roads are compromised, etc. And this is just a quick snapshot from social media where someone is showing their car. That little line in the lower left-hand corner is actually a windshield wiper sticking up, and showing how their car was buried, etc. So this again just paints a picture of the severity of the storm, because these kinds of storms can be, have pockets of more impact, and to be able to understand where the pockets of impact are critically important as well. So those are some of the things that you can derive, leveraging social intelligence and social media filters to get a quick understanding of what's occurring during a weather event. So I just want to end by saying that Everbridge is happy to speak with you about any kind of weather preparations or emergency notifications or critical communications in general. We have over 1,500 customers across many different verticals, so please don't hesitate to reach out to us, and we're more than happy to discuss your challenges and propose solutions. So with that, I want to once again thank our guests from WDT, and I will turn it over for some questions and answers.
Great. Thank you so much, Claudia. At this point, we're going to open it up to questions from the audience. As a reminder, you may submit your questions by typing a question into the open text field in the questions panel and submitting it to all panelists. And we'll answer as many questions as time allows. So our first question, I think, is for the WDT crew. So Steve would like you to either prove or debunk a myth that he's heard, although he didn't say where he's heard it. But he wants to know whether the reason for a lot of the bad weather we've been having this December is because there were so few hurricanes this year during hurricane season.
Oh boy. Meteorologically, the deciding factor whether or not is directly connected to how much warm air you can jam northward towards the pole, up to higher latitudes. And in our diagnostic process, setting up the forecast, the majority of the winter pattern evolution to date has been much more connected to the Asian subcontinent and the Pacific sector, and not so much the Atlantic sector. In fact, one can argue that a lack of substantial tropical cyclone activity in the western Atlantic basin would have left an excess of warm sea surface temperatures, and that kind of setup going into a winter normally correlates to a warmer south central and eastern U.S. And as you saw in some of Dave's verification graphs and my verification graph of the winter to date, the southeast has been warm, but the western two-thirds and especially the northern share of the nation have not. So I would say, in meteorology, it's very difficult to 100% debunk or 100% prove something. In this case, I think in large part our severe winter conditions from the west through the Midwest and Northeast have been more driven by the upstream pattern and not so much by the Atlantic pattern. But I'd say 15 to 20% of the warmth in the Southeast, and thus an enhanced temperature gradient across the eastern part of the nation. And where you have enhanced temperature gradients, you have enhanced jet streams and thus enhanced storm activity. So I would attribute 15 to 20% of the enhanced storm activity indeed to warmer, more moist conditions over the southwest Atlantic basin, which can have something to do with the lack of tropical cyclone activity, getting rid of that warmth during the tropical storm season.
Great, thank you so much. I think we have another question for the WDT folks, and this is actually, I know a few questions have come in throughout the course of the webinar to this effect. So I'll try to paraphrase them with the understanding that some of it's probably been answered. But I think folks found the forecast information very interesting, but they just want to know, is this going to be a bad winter or will it be a mild winter?
Well, you always come back to the maps. The maps give you constantly a take-home message and some bullet points. And I think ultimately the summary answer to that question, Aaron, is it depends on where you live. With the forecasts we have out right now, it depends what you think is a bad winter. If you like severe cold air and a lot of snow and elevated risk for ice, and you live in the plains, Midwest, and interior Northeast, it's probably going to be a bad winter. If you live in the Southeast, you're probably going to continue to escape the worst of the winter so far. The West Coast goes back and forth, but the Pac Northwest is probably more prone to receive additional cold air injections. So 3/4 of the nation probably cold and stormy. The southeast quarter of the nation, I think, is on the outside looking in at the worst of it.
Great, thank you. So this next question is for Claudia. Regarding social networking and social media, obviously there's always a question as to whether posts are accurate or not because they're user-generated. So how do you take that into account when trying to gain intelligence from social media?
Yeah, that's an excellent question. And in fact, we recommend that you can use social media to, not only get a better understanding of what's happening on the ground by looking at, numbers of posts, et cetera, to understand trends, but you can also leverage it for false information as well, and issue, corrections through, social media, whether it's Twitter, Facebook, et cetera. So really, leveraging social media to understand what information out there is of value to you in terms of helping to paint a better picture around situational awareness is important, but also enabling you to leverage it for false information and rumors as well.
Great, thank you. We just had a question come in for WDT. One of the speakers said, we start by reviewing the activity of the jet stream. I believe that was David. And while this seems to establish the weather pattern looking forward, what affects the jet stream activity in the first place?
Short answer there is the mid-latitude jet stream is set up by temperature gradients. So where you have a very large area of very warm air in the southern latitudes and colder air, much more dense north of there, you set up a very strong temperature gradient. Jet streams set up virtually directly over the top of where that temperature gradient lies. However, a very important point for winter weather forecasting that Dave helped make, and I alluded to very briefly in our process slide right out of the gate. Oddly enough, tropical thunderstorm activity can be a very important driving force in how the winter weather pattern changes, especially downstream from the Pacific over the North American continent. And in that case, the jet streams are not driven by temperature gradients. The farther south you go in the tropics to the subtropics, down south of about 30 north, you can have jet stream enhancements and actual jet stream production out of the tops, the northern poleward side of these large, coherent, focused areas of thunderstorms. There's a lot of heat released in the middle of those complexes, a lot of momentum released and transported poleward, and that momentum has to go somewhere. And in the northern hemisphere, it goes poleward and turns to the right and accelerates. And so we get subtropical jet streams that extend across the oceanic basins. Those are very important for our weather picture because they help set up other storm systems and they help push the jet stream around in buckles. That's how one of the ways we get very warm air upstream over Alaska and a lot of downstream cold air digging southward and buckling the jet into the middle part of North America.
Great, thank you so much. I think we have time for just one more question, because this one comes in for Claudia. Particularly when we deal with significant ice or snow events, it impacts electric utilities as well as causes overloading of cell phone towers. So how do we get around that in order to message out to residents or employees?
Yeah, it's an excellent question. So again, we always recommend multiple contact paths. So I would consider, SMS as well as email. And I would also like to recommend that you consider using the Everbridge mobile member application because that's a lightweight application that gives you the two-way communication that we talked about earlier and can be used if landlines aren't functioning, etc.
Great, excellent. Thank you so much. So I am sorry to announce that we have run out of time, but I want to thank Mike, Jason, David, and Claudia for a great session, and thank all of our attendees who were able to join us today. So if you missed any part of the webinar, be sure to look for the slides on everbridge.com/blog. They'll be posted up in the next week or so. You'll also receive an email with a link to the recording in the next few days. If you haven't already, please take a moment to follow us on Twitter at Everbridge and join our group on LinkedIn, Everbridge Incident Management and Emergency Notification Professionals. For those of you interested in requesting a demo of the new Everbridge system, please visit everbridge.com/request-demo. And I believe we have contact information there as well if you would like to follow up with either of our experts. And we'll also be following up with folks who didn't have time to have their questions answered as well. So thank you all again for your participation in today's Expert Insights webinar, Winter Weather Forecast for 2013-2014, Predictions and Best Practices with WDT. And we hope to see you all online again soon. Have a great day.